Okay, so welcome everybody to day 19 of the SBI for You course. And things are going really well. I'm really happy with seeing how many people are logging on every day, which is excellent. It's going to make this course so much easier if you're logging on every day and then you're recapping what we did yesterday. If you try and log on every 3 or 4 days, it's very difficult. It's like showing up for school every 3 or 4 days. It would be impossible to try and do like a chemistry or a biology or a physics course where you only attend school every 3 or 4 days, right? Now, in terms of the lecture, so some people liked it, some people didn't like it. That's just how things are going to happen. No learning skill or learning style works for everybody. So what I'm going to do is I'm going to do a combination of a little bit of both. Okay, I won't do that many really long lectures like the last one was half an hour long. I'll try and break them up into some shorter ones, but I think it's very important. So some of you picked up on, this is going to help me prepare for university, and it truly is, because that's really what you're going to get in university. And if you're having trouble, getting the PowerPoints printed out or getting them to show up on your screen, those are all problems that you're going to have to sort out next year. And I know it's frustrating, and technology is, but you're going to have to try and figure out how I can make this work. Because again, primarily, at least the universities that I attended in a science program, it's going to be lecture based. Okay, and that was only a half an hour lecture. Imagine now, 4 times that amount in like a 2-hour or a 3-hour lecture. Okay. So I'll do a little bit of that. Thank you for your input, and I mean that means the world to me because I'm trying to make this course the most beneficial for both of us. Okay, so our next topic we're going to go through today is active transport. So we've already gone through passive transport. Okay, and the big thing on passive transport is we don't need energy. Okay, so it's not going to take we're going to have to burn any of our food or any of our macromolecules in order to do it. So it just happens naturally, which is key, right? When we're breathing, we just want oxygen to go into our bloodstream. We don't have to constantly be trying to suck that blood or trying to suck that oxygen into our bloodstream using energy. So passive diffusion, which we've gone over before, is simply going down a concentration gradient and not using any energy. So there's a couple things we're going to talk about today, and it's going to be active transport, which is very, very different. Okay, so to show you, I'm just going to do a little quick thing up here with some PowerPoint. So let's take a look at, here's our cell. So if we take a look at our first one here, okay, these substrates could be anything. They could be glucose, they could be oxygen, they could be an ion like sodium or potassium. But the key thing in here is right now I can use passive diffusion. And why I can use passive diffusion is because outside the cell is highly concentrated. Okay? And the inside of the cell has got low concentration. So what's going to happen over time is these substrates are going to go down their concentration gradient. So this thing is going to start moving into the cell. And these are going to keep moving into the cell. And they're going to keep moving into the cell until we get it relatively equal. So now I've got 4 of them inside the cell, and I've got to go, let's say 4 outside. Let's just delete this one to make it easier. So now passive diffusion will stop. Okay, and there's the problem with passive diffusion, is it's going to stop right now that they're equal concentrations. So we need to have a concentration gradient in order for passive diffusion works. Well, that's not always possible. Okay? What happens if we don't have a concentration gradient? Okay? Like say we take a look at something like this. Okay? Say this substrate happens to be a very dangerous ion, like say mercury. So say you ate a little bit of mercury, and now you have mercury ions inside your body. Okay? They're not going to be very good for you. You definitely don't want to have any mercury. Okay? Well, what if you have a little bit of mercury inside your cell, and you don't want to have any mercury in your cell, absolutely zero? Okay? But what's going to happen, if according to passive diffusion, is these mercury ions are going to keep secreting into your cell. Well, you can't have that. So you actually have to work against the concentration gradient. You have to take any mercury that's already in your cell and actually work against the concentration gradient to get it back out. And the concentration gradient is going to try and push it back in. Well, then you're going to have to actively pump that thing back out. Okay? Now, passive diffusion won't enable us to do that. Passive diffusion won't enable us to work against the concentration gradient. So in order to do that, we have to use active transport. And active transport basically works against a concentration gradient, but it requires energy. Okay? So we'd love to use passive diffusion for everything because we don't need to use energy for it. It's very cheap. It's very easy to do. We will always prefer to use passive diffusion. The only times that we'll use active diffusion is when we have to, okay? Because it's going to require energy, and it's when you have to go against a concentration gradient. Okay? So in this case, I have a toxin inside here. So any kind of poison that you have inside your body, okay, your cell can't have any of it. So your cells are going to try and excrete it against their concentration gradient. Now, there's a couple other times that this is very useful. Okay? Say you produce a waste. So you have a waste product. So your cell produced something, and now you have a waste product. Well, you don't have a big enough concentration gradient to get it outside the cell. It's not highly concentrated inside your cell. It's just got one substrate, and it could have 0 outside there, but there's not a big concentration gradient. It's not like there's 50 of them and then 0 outside, which would drive them out. Now, the bigger the concentration gradient, the faster they're going to come out. Well, if you have this waste product and you have only one of them, but you want to expel it, okay, you're going to want to use active transport. Because there's not enough of them inside here, it's going to be hard to use passive transport, so you're going to want to actively pump this thing out. Right? And that's, again, another example of using active transport. Right? The other example of using active transport is, so say we have a white blood cell, and this could be a white blood cell, so let's just put in here, a white blood cell. Now this is also called a lymphocyte, just another term if your previous teachers were really term heavy. Okay, it's a lymphocyte, or a macrophage would be another simple term for it. So this could be, say, a bacteria. So your white blood cells are going to go in and they're going to want to eat this bacteria. They're going to actually destroy it. Well, what's going to happen is we're going to have to bring this entire bacteria inside this cell. Okay, so this isn't like bringing an ion in or bringing glucose in or bringing like a small piece of water in. This is a giant cell that you're bringing in. So I've made it a little bit bigger to emphasize that it's a bacteria. So we're going to bring this giant, huge cell and try and get it inside here, which is going to be very, very difficult. Okay, we're going to have to use energy in order to do it. And that's what our topic is on bulk transport. So bulk transport is bringing giant things into the cell, or if you had, say, a bunch of stuff inside here that you wanted to get rid of, you could exit that way. So that's called bulk transport, which also uses active, or a form of active transport. So when we go back here to our contents, let's go to content. And we've already gone through passive and parts of active transport. So I'd like you to click on here. And we've already gone through the top part. That's what my lecture was on, and it was a really long lecture, but I think I'm pretty thorough. So you're going to want to review this active transport right here. Okay, go through here. There's some other links that you can go through. And in your portfolio, some key things that I'd like you to add to your notes. So that's active transport. And the next thing we want to do is our last part. So let me just move this over here. And click on Unit 1. And we're going to go to bulk transport. And we're going to go through what bulk transport is. And there's some other links and then some things I'd like you to add to your notes. Okay? Now, other key thing is we're going to have a quiz coming up. Okay? And I know some of you are maybe a little bit nervous about how this quiz is going to work. Okay, we're going to do some prep for it. I'll give you a review for it. Basically, what you're going to have to do is you are going to have to log in on a certain day. I'm thinking we're going to make it a week from today. So next Thursday, we're going to have a quiz. Okay? Now, on that Thursday, you can log on anytime during the school day. It has to be during the school day. So from 8 until, we'll put it till 3 o'clock. Now, so you can log on at any time during there, but as soon as you log on, you only have 2 hours to complete the quiz. Okay? We'll talk a little bit more about that, but I wanted to give you a heads up, just so you know that you have to log on 1 week from today, next Thursday. Okay? Thanks, and I hope you guys enjoy active transport. Again, a reminder of your cell. It's like a city assignment that is due tomorrow.